right, so first let's take a look at what equivalent expressions are. And then I have some examples and some steps for you to follow that will be helpful. Okay, so let's go ahead and get a definition for equivalent expressions put in our notes. Okay, so equivalent expressions are expressions that work the same even though they look different. So they're expressions that work the same even though they look different. So let me do an example so that you can actually see what that looks like. I'm going to do a really basic example, but we'll ramp it up during the lesson. So let's say that, so we're going to say R5 times the whole thing, 6x plus 9, and the expression 30x plus 45 equivalent. That's what we're going to try to answer here. Well, what I do is equivalent is just a fancy word for they're equal. So I'm going to take each of these expressions and set them equal to each other. So I'm going to say 5 times 6x plus 9 is equal to 3x plus 45. So basically, if this is true, the expressions are equivalent. If this is not true, then they're not equivalent. So we're just going to simplify both sides. I'm going to put a little line here just to keep them separate. Actually, this is done for us. You can't simplify that any further. But if we look at this side, we can distribute. So this will be 30x, and then 5 times 9 is 45. And this was already simplified. So are those two expressions equivalent? Yes. Good. So let's just write down the steps to discovering whether or not these are equivalent. It's just so that we have them in our notes, because I'm sure all of you guys read all of your notes the night before a test, just to make sure you don't miss anything, right? Oh. Surely you do. All right, let's take a look at step 1. We're going to set them equal to each other. By them, I mean the two expressions. So I set them equal to each other. Then we're going to simplify both expressions completely. So simplify completely. And then you're asking this question, are they equal? Okay, so those are our steps for identifying equivalent expressions. Now this is a pretty basic concept. You guys get the concept, right? You're just simplifying them, seeing if they're equal, and that will tell you whether or not they're equivalent. Yeah. So let's amp it up. Let's do a longer expression, set of expressions to see if they're equivalent or not. I'm gonna skip ahead. I'm not gonna waste time asking the question. I'm just gonna set the two expressions equal to each other so that we can see. Okay, I'm gonna put my line here just to keep it separated. Gotta keep it separated. Okay. Now we're gonna distribute wherever we can and then see if those two expressions are equivalent. So when I distribute here, I wanna make sure that I'm distributing the whole thing, -5. And I'm gonna ignore the 10 for right now. I'm just gonna bring it down because it is not a part of my distribution. Also, -5r is not a part of it. So I'm going to distribute -5 to -2r. So that's going to be +10r. Then -5 times -13 is a +65. And then I'm going to bring that last term down. All right, let's take a look here. We can combine like terms. So 10r minus 5r is 5r. And then 10 plus 65 is 75. Now for this one, we've got a big distribution to do. We've got 4 terms inside of the parentheses. So we're going to distribute 5 to each one. So this will be 10 plus 10r plus -65 plus or minus 5r. And now I can combine like terms. So 10r minus 5r is 5r. And then 10 and -65 together is going to be -55. Are those the same things? No. No. So these are not equivalent. The answer is no. And if you were rushing through, you may not have caught it because these look very similar, don't they? It's just that one little sign that was a difference. So that's why it's really important to make sure that you take the time to actually do all of the work so you don't make errors like that. Okay, let's do another example. Or actually, sorry, I'm going to have you practice. That's what I meant. So let's do 3p minus 4 times the whole thing, 4p minus 2. And we'll see if it's equivalent to -16p plus 3 times p minus 1 plus 11. Okay, give that a try. Yeah, on the side counter over there, there's some pencils you can borrow. You guys are really quiet today. That is right. What do you guys think? Are these equivalent?
Yeah.
Yeah? No? I hear some yeses and some nos.
Yeah.
Okay, well let's try it out. Let's check it out. I'm going to divide this out. Okay. So I'm going to distribute first. So this will be negative 4 times 4p is negative 16p. And then negative 4 times negative 2 will be a positive 8. But I can't forget about that first term. Let's bring that down. And then I can combine like terms right here. So this is 3p and negative 16p. So this should be negative 13p plus 8. So that's that side. Let's try this side over here now. I'm going to bring down my negative 16p. Then I'm going to distribute. So this will be 3p minus 3. And then I'm going to bring down my 11. And let's combine terms here. We've got our p's together. So this will be negative 13p. And negative 3 and 11 is positive 8. I would say yeah. Yes. Any questions about that? Okay. Okay, and I want to just clarify something too. Because this kind of gets people sometimes. Is negative 13p plus 8 the same as negative 8 plus 13p?
No.
Are those the same?
No.
Why? They look pretty similar. Urban.
Okay, so in the first expression on the top, we have a negative 13p and a positive 8. But on the bottom expression, we have a negative 8 and a positive 13p.
Yeah. Robbie.
I think it might hurt. Never mind.
Okay, if I was going to change the order in a correct way, how would I do that? So if I wanted to switch the order of this expression, how would I write it? Carl, go ahead.
8 minus 13p.
8 minus 13p. Awesome. Because that sign in front of it is like stuck to it, like glue. Okay. And some of you had a hard time on the quiz because you put this. Technically correct, right? But when we're getting into huge, long equations, we don't want to have all that extra signage. So we can just do away with the parentheses and the addition sign, and it just simplifies it. It's just good math form to try to make sure that we use as few symbols as possible. How are you guys feeling?
Good.
Good? Okay. I really want to make sure you have time for your task today. So I'm going to give you the task, and if you finish the task, then you can definitely work on your homework too. This is my favorite task, you guys.